Okay, class, let us continue with some of the example problems that I'm going to display here and kind of give you some more insight of how to do these problems. I hope these example problems are very beneficial and helpful to you. Kindly please give me some comments as to what you think of the example problems in the video as well. Okay, so going to do some example problems here. So we are asked to, in this case, we're asked to find the sum or the difference and write each form in A plus BI form. Okay, so the first one is going to be 3 minus 2i plus 7, negative 7 plus 9i. Okay, so when we do that, we want to be able to open up the parentheses as our next step. So that's going to be 3 minus 2i minus 7 plus 9i. And when we solve, we're going to bring the real terms together, such as 3 and negative 7. Those are the real numbers, and then the complex numbers will be negative 2i and 9i. So 3 minus 7 will typically going to give us negative 4, and then negative 2i plus 9i is going to give us a positive 7i. Okay, so this is your answer right here. Okay, remember, they want the answer in the A plus BI form. Again, your A is a real number, and then your BI is your complex number. Okay, so let's try another one, B. We have here 3 minus 2i minus 7 plus 9i. Okay, so we want to resolve this. We want to open up the parentheses as our next step. It's 3 minus 2i. Well, this minus times this minus is a positive. Remember, negative times a negative equals negative. Negative times a positive equals a negative. Positive times a negative equals negative. Negative times negative is a positive. And then negative times a positive is negative. A positive times a negative is a negative, and of course a positive times a positive equals a positive. Okay, so kindly remember this. This is very important. So this negative here times this negative 7 gives us a positive 7, and then this negative times this positive gives us what? A negative 9i. Okay, because we want to be able to open up the parentheses. So when you open up the parentheses, the sign outside the parentheses takes control of whatever signs are within the parentheses. Okay, so we're going to bring the like terms or the real numbers together. That's going to be 3 plus 7 minus 2i minus 9i, and we shall get 10 minus 9i as our answer. Okay, that's our answer. Okay, so let's look at another one. Let's look at C, whereby we have the square root of 2 minus 3i plus 2 root 2 plus 3i. Okay, so in doing so, we now can open up the parentheses as a next step. So that's root 2 minus 3i plus 2 root 2 plus 3i. And that's going to give us, we want to bring the like terms together, or the real numbers together, and then the complex numbers together. So that's going to be root 2 plus 2 root 2 minus 3i plus 3i. Okay? And now we see here that this is a minus 3i and a plus 3i. These can go to 0. Right? They cancel each other out, so we're left with only 3 root 2. Right? And in your question, in your answer, you want to be able to put 3 root 2 plus 0i. Okay? And that's your answer. Okay? Let's look at another problem. Now we are asked here to, in this case, so let's move forward. We want to deal with multiplication. Okay, we're asked to perform the desired operation. And now we have A, which is 2i times 4 minus 3i. So when we want to take it a step further, we want to be able to use FOIL as we did before. That's the first step, and that's the second step. So that's going to be 2i times 4 minus 2i times 3i. Right? That gives us 8i minus 6i squared. Well, we know that I squared is what? Okay, from our expression here, we know that I squared happens to be negative 1. Okay, so with that being said, we can come back here now and say we can now say that 8i minus 6 into negative 1. Alright. Equals 8i plus 6. So we can rearrange this and say 6 plus 8i. Okay? And that's in your a plus bi form. And this is your answer. Okay? Now, let's try B. We have negative 2 minus I times 3 minus 4i. Okay, again, we can use FOIL. Okay, this is 1, 2, 3, 4. Okay, so we do step number 1. It's going to be negative 2 times 3, right? It's going to give us negative 6. Okay, and then we have negative 2 times negative 4i. That's going to give us a positive 8i. Then we have negative I times negative 3, which gives us negative 3i. And then we're going to have negative I times negative 4i. That's going to give us a positive 4i squared. Okay? And now we want to be able to simplify even further, so there's negative 6 plus 8i minus 3i plus 4 times negative 1, because I squared equals negative 1. And we're going to get negative 6 plus, plus 5i, and that's going to be negative 4. Okay, so now we can take it a step further and say these are the real numbers, negative 4 and negative 6. That's going to be negative 10 plus 5i. That's going to be your answer. Okay, and let's try another one. Let's try C. We're going to have and they want us to perform square root of 2 minus I squared. Okay, so our next step would be negative 2 minus I times negative 2 minus I. And when you do that, you're going to get, again, we're going to do FOIL. Okay, and when we do that, we're going to get root 2 times root 2, right? And that's going to be negative I root 2. And this is 1, this is 2, this is 3, and this is 4. So this is the 1, this is the 2. And then for the third part, we're going to get negative I root 2. And then for the fourth part, we're going to get negative times a negative is a positive. Positive I squared. Okay? So we take it a step further. Root 2 times root 2 is nothing more than 2. Then we have a negative I root 2 and negative I root 2. That means we have a negative 2I root 2 plus I squared. Well, I squared is negative 1, so that's 2 minus 2I root 2 minus 1. And then 2 minus 1 happens to be 1 minus 2I root 2. And this is your answer here. Okay? Now, we can go a little further. Now we want to deal with the conjugate aspect of our section. And they ask us to find the product of the given complex number and its conjugate. Okay. Now we have here, keep in mind that the conjugate, or the conjugate of this z, which is a plus bi, the conjugate is going to be z with a bar on top of it equals a minus bi. Okay. So again, this is the conjugate of a plus bi. Okay. So if you're asked to evaluate negative 5 plus I, the complex conjugate of negative 5 plus I is, root 5 plus I is root 5 minus I. This is the complex conjugate of root 5 plus I. Okay? So if you want to be able to find the product of this, it's going to be root 5 plus I times root 5 minus I. Okay? And again, we can use FOIL as we've been doing. Okay? And when we do that, we're typically going to get root 5 times root 5 minus I root 5. Okay? Plus I root 5 minus I squared. Okay? And then our answer typically is going to be 5 plus 1 equals 6. Because root 5 times root 5 is nothing more than 5. And these cancel each other out. And then we know that the square root of I squared is negative 1 times this minus sign here gives us a positive 1. Okay, making 6 is our answer. Okay? Let's try another one. So we have here, we have to find the product 1 over 2 minus 3i. So we're going to multiply this by its complex conjugate, which is 1 over 2 minus 3i times 1 over 2 plus 3i. This is the complex conjugate. Okay? And in doing so, we're going to use FOIL again. Okay? So our solution is FOIL technique. That's going to be 1 over 2 times 1 over 2, okay, plus 1 over 2 times 3i minus 1 over 2 times 3i minus 9i squared. Okay, so 1 over 2 times 1 over 2 is going to be 1 over 4. And then since this is a positive, this expression here, if you look at this, this is a positive 3i over 2, and this is a negative 3i over 2. So they cancel each other out. Okay, just like saying 3 over 2 minus 3 over 2 is going to equal 0. So that makes it go to 0. Okay. And then we're left with, come back here, we're left with this negative 9 into negative 1 because I squared is negative 1. So we have 1 over 4 plus 9, okay, equals 9/1/4. And this is the proper fraction. Improper fraction would be 37 over 4. Answer. Either one is correct. Okay. Again, this is your proper fraction. And this right here is your improper fraction. Okay. Let's try to evaluate something a little bit more involved. So we have our number is, we're going to find the product of this value, which is root 3 over 2 plus 1 over 2i. Right? So we have to multiply this by its complex conjugate, which would be root 3 over 2 minus 1 over 2i. Okay? So don't fret. If we were to do this, it's going to, again, we use FOIL again, and it's going to be root 3 over 2 times root 3 over 2, right? So we're going like this, going like this, then we go like this, then we go like this, okay? And this is 1, 2, 3, 4, okay? So we've done the first one. This is 1, okay? And then we're going to do the second one, which is going to be negative 1 over 2i. So negative times root 3 over 2. Okay, this is 2 plus 1 over 2 times square root of root 3 over 2. This is I here. This is 3. And then minus 1 over 2i times 1 over 2i. This is minus, and this is our fourth one. Okay? Okay, so now we have, again, these two cancel each other out because of the negative sign here and the positive sign here. So we're left with root 3, over 2 times root 3 over 2 minus 1 over 2I times 1 over 2I. Okay, root 3, when we square these two up, you're going to get 3 over 4. Okay, again, plus the 0 for this aspect of these two to go to 0. Okay, minus 1 over 4I squared, because 1/2 times 1/2 is 1/4. And the I times the I is I squared. Okay, and now we get, when we simplify this, we're typically going to get 3 over 4. Again, your I squared is negative 1. Negative 1 times 1 over 4 is going to be a positive 1 over 4 equals 1. So the answer is 1. Okay. Now let's do a quotient. In this case, we are asked to, let me use a different color here, green. We're asked to write each quotient in the A plus BI form. So we have 5 plus I over 5 minus I. Okay, and then we take this, if you want to solve this, it's going to be 5 plus I over 5 minus I times the complex conjugate of the denominator, which is 5 plus I over 5 plus I. Okay, then we simply use FOIL again to be able to solve this particular problem. And then we're going to get, so it's going to be 5 times 5. Then let me use a different color so you can see. It's going to be 5 times 5, 5 times I, 5 times 5. I'm sorry, let me do this correctly. So in this case, we're going to, so this is going to, it's going to be a first one. It's going to be a second one. Use a different color. And then we're going to do our I. It's going to come here, and come here. Okay. Likewise here, here. Different color. And we're going to go here and here. Okay. It seems a little convoluted, but it's not. So all you're really doing, if I may break this down here, it's going to be 5 plus I times 5 plus I all over 5 minus I times 5 plus I. That's all we're doing. Okay, so we're just foiling. So I don't want this part to confuse you. So I'll erase this part, and we can do it this way. Okay. Okay, so we can just expand it that way. Okay, so when we do so, we're going to get 5 times 5. Okay. Right. Plus 5 times I. Okay. That's going to be I times 5, which is 5I. Okay. And then we're going to get I squared plus I squared. And then we can now go to our denominator. 5 times 5. Okay. 5 times I. then negative I times 5, that's negative 5I, and then negative I times a positive I, which is going to be a negative I squared. And then when we do the math, this is 5 times 5, which is 25, and this is a positive 10I, and then it's our positive I squared divided by, we see here that this is positive 5I, negative 5I, they cancel each other out, so we're left with 25 minus I squared. Okay, so we know this I squared can be a negative 1, so we get 25 plus 10I minus 1 divided by 25 minus 1 equals 25. Sorry, that would be 24. Just erase this part. So 25 minus 1 gives us 24 plus 10I divided by 26. Okay. So we want to put this in our A and B. A plus BI form is going to be 24 over 26 plus 10I over 26. And then you can reduce this even further. It's going to be 12 over 13 plus 5I over 13. Okay, and this is going to be your answer. Okay. Let's see. So we have room for one more. Okay. We want to be able to express this expression. Okay, so in this case, this example problem is asking us to write each expression in the A plus BI form. Okay, so we have root negative 36 minus root 49. So if we solve this, we can say negative 1, square root of negative 1 times the square root of 36 minus the square root of 49. We take that a step further, you're going to get 6I, right? Because this is going to be I, this is going to be 6, and then minus 7. So in the A plus BI form, it's going to look like this. It's going to be negative 7 plus 6I. And this is our answer. Okay. I hope this helps. Kind of let me know. This is about 30 minutes. I didn't want to go too long, but let me know if this example problems help you or not. Thank you very much. I appreciate you. Thank you.